2. Requirements of a process. Initial state. The initial state is correct if the following conditions are met. 1. The clamping cylinder is loosened. 2. The holding cylinder is retracted. 3. The releasing cylinder is stretched out. 4. The lifting cylinder is retracted. 5. The stretching cylinder is retracted. 6. The emergency stop button is not pressed. 7. The signals of the corresponding sensors are correct. 8. The unit has been connected with the power supply and air source. The yellow pilot lamp lights if initial state is correct. Otherwise, the yellow pilot lamp twinkles at the frequency of 1 Hz, and the error code is modified as 310. We should detect the initial state before running. Running state. The system state changes to running state after the start button is pressed if the initial state is correct. Then the green pilot lamp lights up and the yellow one turns off. Then the detecting of initial state is forbidden. The system will execute the assembly process according to the requirements of process in running state. There are 2 models of running. The system will run in manual mode if the switch is off. Otherwise, the system will run in automatic mode. In manual mode, the system will perform one assembly process each time the start button is pressed if the execution conditions are met. In the automatic mode, we press the start button once. The system will execute automatically if the execution conditions are met. Both models can assemble the part into the workpiece accurately according to the requirements of a process. Stop state. The system will run in stop state if the stop button is pressed in running state. After finishing the process of assembly, all actions are forbidden in stop state and the red pilot lamp lights. The green pilot lamp turns off. Then the error code is modified as 330. The system will change to stop state immediately whenever the emergency stop button is pressed, and the error code will be modified as 331 in this condition. Reset state. The system will run in reset state if the start button is pressed for 2 seconds in stop state. Both yellow pilot lamp and the green pilot lamp light in reset state. The system will reset automatically if the switch is on. Otherwise, you need to press the start button to reset the system manually. The reset process is finished if the state of all cylinders and the values of the all temp data are the same as the initial state. You need to press the start button over 3 seconds to restart the system with initial state after all the devices have been reset. 3. Ideas of programming. The structure of a program. The program is divided into 9 modules based on the functions according to the requirements of a process. The 9 modules are as follows. 1. DB2Assemble unit is a global background data block. It is used to store the symbols and data related to assembly unit. 2. FC2Assemble unit single manage is a FC block. It is used to manage the symbols and data of an assembly unit. 3. FB2 System State Detect is a FB block. It is used to change the states of assembly unit. 4. FB2Assemble unit to lab control is a FB block. It is used to control pilot labs of assembly unit. 5. FB2 Supply Workpiece to Auto is a FB block. It controls the automatically feeding process of parts to assembled. 6. FB2Assemble process to manual is a FB block. It is used to control the assembling process manually. 7. FB2Assemble process to auto is a FB block. It is used to control the assembling process automatically. 8. FB2Assemble unit to reset is a FB block. It is used to control the reset process. 9. FB2Assemble unit to error control is a FB block. It is used to modify the error code of assembly unit. The process of the program. 1. The process of system state. The system state is composed of initial state, running state, stop state, and reset state. The transformation between each state is shown in the system state flowchart. First, the system begins with initial state. Second, it will run in running state when the start button is pressed if the initial state is correct. Unless you debug all failures, the system stays in initial state. All the assembling process will be done in running state. Third, it will run in stop state when the stop button or the emergency stop button is pressed according to the requirements of a process. Fourth, it will run in reset state if the start button is pressed for 2 seconds in stop state. Finally, it will restart with initial state if the start button is pressed for 3 seconds and all failures are debugged correctly in reset state. 2. Automatic assembly process. The process of assemble will be executed in running state. The permission for assembly is estimated firstly. Then the system will execute the process of assemble if all conditions of assembling process are met. After getting the permission, first, the lifting cylinder falls. Second, the clamping cylinder collapses to grip the part in the right trail of a rotating mechanism. Third, the lifting cylinder lifts. Fourth, The stretching cylinder stretches out. Fifth, the lifting cylinder falls again. Sixth, the clamping cylinder loosens to release the part into the workpiece. Seventh, the lifting cylinder lifts again. Finally, the stretching cylinder retracts. 3. Process of supplying. The process of supplying will be executed in running state. The permission for supplying is estimated firstly. Then the system will execute the process of supplying if all conditions of the assembling process are met. After get the permission. First, the holding cylinder stretches out to hold the upper part. Second, the releasing cylinder retracts to release the part to the left trail of rotating mechanism. Third, the releasing cylinder stretches out. Fourth, holding cylinder retracts. Programming steps. Since the hardware has been configured, the user data types has been created in Project 1. The task remained are assigning variables, creating background data block, creating functional blocks, simulation, and debugging.